Okay, so here's the Excel project with all the data that was entered. So you can see that what I've done is I've entered it all, and there's a person number, the meter that they were using, the resistors, the person, well, were 6 stations. So this first day, person 5 had meter 5 and resistor 5. But the second day, it would be some person with a higher number, and they would have the same meter and the same resistance. And then what happens later is they switch meters. Keep the same resistors, but switch meters. Then you have the nominal resistance. I have 220, and then you have the measured resistances. These are the numbers you entered into your sheet. Then there was the method. Method 1 was where you held the two ends of the resistor by your thumbs, and that was where your body could actually contribute to the resistance measurement. The second method is where you held the two probes, held the center of the resistor, and pushed it up against the probe so your body was not part of the circuit. So method 1 was used by everybody the first day, except for Alexander Taylor, who did the second method. Then the second day, there were some people in the first group that did method 1 for the first 2 readings, and then we switched to method 2. The second group, the second day, all did it method 2. So the biggest thing that there's going to be 2 things that we're going to do. One is we're going to do a histogram of the 2 methods looking at the 2 resistors types, the 2 resistors. There's 220 ohm resistor and there's the 10,000 ohm. Now the numbers are in decimals, so these are kilo ohms. This is the nominal resistance in ohms. Anyway, we're going to do 2 histograms comparing the 2 methods for the 2 different nominal resistances. Then we're going to look at the 6 different meters that were used, and we're going to compare that using method 2 for the 10,000 ohms and method 1 and 2 for the 220 ohms, because we'll find out that the 220 ohm one had about the same distribution with either technique, but the 10,000 ohms were reasonably significantly affected by the method that we used to measure. Okay, so that's the background. So we're going to do some sorting first, and we're going to sort by, let's see, what did we sort by here? We're going to sort by nominal resistance and method. So the way you do that is you highlight all the data. So you got to drag it all the way down to the bottom. So it takes a while to do that because there's a lot of data. So you see the slider moving on the right hand side. Okay, so there we go. Got all the data. Then you go to data on here on the menu and sort. So there's 3 choices. One takes the first column and does it alphabetically or numerically from A to Z or from 1 to whatever number. This one does it in reverse order. We're going to do 2 things. So we're going to click on this box. And first we're going to sort by method. Actually, no, we're going to sort by nominal resistance. So we can click on sort by and we'll go nominal resistance, smallest to largest. That means we'll have the 220 ohm resistors first and then the 10,000 ohm resistors second. Then we're going to add a level. So now that means we're going to sort on 2 things. The second thing we're going to sort on is method. And then we're going to say OK. Now you didn't see anything happen because the first bunch of stuff didn't get changed, but if we scroll down, you can see these are all 220 ohms. At some point, the column F will change to 2s. Okay, so there's 2s. Then what will happen at some point, column D will change from 220 to 10,000 back to method 1, and then it'll go to 10,000 method 2. So that is the sorting we're going to do. Okay, so we're going to use that sorting to come up with a histogram, or a couple of histograms. So to do a histogram, you've got to install what's called an add-in. So you go to File, Options, Add-ins. So this menu down here, go to Add-ins. Now I've already added it. It's called the Analysis Tool Pack. So you can see there's an Analysis Tool Pack VBA. This will also be a choice, Analysis Tool Pack. So click on that. And if you come down here, it will, well, let me show you what happens if I, no, actually, so let me just click on that. And what it should do is manage add-ons. Let's go to there. And what should come up is the add-ins. And we're going to click on Analysis Tool Pack. So we'll say OK. And what will happen on the Data tab is you'll now have this choice of data analysis. Before you didn't have that. So let's review that again. You go to Options, Add-ins, click Analysis Tool Pack, which you'll have down here. I wonder if I can remove it or not, just to show. Let's see if I can undo it somehow or another so that I can show you how to do it. Well, let me see if I can remove it here. So what I'm going to do is I'm going to remove it. Say OK. Okay, now let's try it again. See if it shows it not being there. Add-ins. Okay, so you can see I've taken it out. So this will be like you have. So you go to Analysis Tool Pack, and then you go to Manage Excel Add-ins. Say Go. Click Analysis Tool Pack. Say OK. And now you can see how it shows up here. So that's what you'll end up having to do. Okay. So let's click on Data Analysis. Now the data analysis has all these different kinds of statistical things, descriptive statistics, all this, what does it have? T-tests, Z-tests, regression. The one we're going to be using is histogram right there. So if we click OK, you come up with this dialog box. So we're going to have input range, bin range. We're going to choose chart output because we want to draw a histogram. Now the input is going to be the measured values. The bins are how we categorize these values for a histogram. So we're going to break it up into, let me cancel that for a second. So we'll cancel that. I'm over here with just, so we're going to create some columns over here. And these are our bin ranges. So we're going to start with 200 because that's about as low as we go as far as the resistances are concerned. Our nominal is 220. Then you choose a bin width, which is going to be 2 units. So we write 202. 200, 202. So now we can fill this out by highlighting these two cells and dragging it down. And we want to get to about 240. Well, that's not quite there. So let's highlight those two cells and drag it down. So we're going from 200 to 240 with 220 being in the middle. So what happens is you would come in here and say, okay, 219, where does that fit? Well, these bins are, this is like 218.0001 to 220. So they put these numbers in different categories. Here's another one. Let's find one that's low, 214. So that would go into this bin. It's kind of like having a bunch of mail slots on the wall, and you're putting people's mail into the slots, and then you would count how many pieces of mail they got. So that we're using, instead of names on the slots, we're using numbers. Okay, so those are our bins for the 220 ohm resistor. For the 10,000 ohm resistor, and because we're doing it in kilo ohms, we're going to start at 9.2. We're going to increment by 0.05. So we're going to do that, and we want to go from that up to 10.2. Now the nominal is 10, but we ended up with numbers mostly less than 10. So we're going to bias it a little bit. Whereas for the 220s, there were the average is a little less than 220, but it wasn't that far. So these are the bins. So you need those numbers. Okay, so we have our data. We have our bins. Now, we're going to have to specify some ranges for the data. So what I'm going to do is ask you to write it down on a piece of paper. So all of the data is in column E. So we're going to start from cell E2, because that's right where this is, okay? And we're going to go down until we find the place where this changes from 1 to 2. So these first bunch are using method 1. So it's about a quarter of the way down. But I'm just using my cursor or a roll on my mouse to get until I see 2. Okay, so you see I have 2. So the end of the range is that one, and you can see it's 415. So we're going to go to E415. So that's the 220 ohm meter 1. Then we'll go E416, which is right here, because now you're changing to method 2. And we're going to go down until we change from 200 to 10,000. So again, I'm using my wheel to go down through the data. Okay, there we go. There's the change. So that's the end of the second range. So that's E, and the row is 763. So that's 220 ohm nominal method 2. Then we're going to start at E417. That's 10,000 ohms method 1. So that is E764, which I did wrong. Let me fix that. E764. And then we wheel it down here till this becomes 2, method 2. There we go. So there's 2. So the end of the range is E1144. So write that down. That's 10,000 ohms method 1. And then we're going to go E1145 to the end of the data. And you could go over here to the slider on the right hand side. So that's the end of the data. That's E1535. Okay, so now we're ready to make a histogram. So we go to data analysis, choose histogram, say OK. So the input range are these ranges we just wrote down. And we're going to do, the first one is going to be E2 colon E415. Okay, so that's the input data. Then we have the bin range. So we'll click on the little arrow, and we're going to highlight the 220 ohm bin range, and then push enter. We're going to put the result on a new worksheet ply, and we're going to have a chart output. And we're going to say OK. So here it is. Now what we want to do is we want to make this graph bigger. So click on the graph, grab the corner, stretch it out. So that's my histogram. And what it's saying is that 120 readings were put in this bin, which I can't remember whether it's 216 to 218 or 218 to 220, but okay, so that's the histogram for method 1. So let's actually go to design, select data, edit, and we're going to give this name, series name, we'll call it method 1. And what that'll do is it just changes this legend over here. Okay, now back to the sheet 1. Now we're going to do the second histogram. So we're going to go to data, data analysis, histogram. Okay. Now you can see it still has the numbers in from last time. So we're going to change this, instead of going from E2 to E415, we're going to go to E416 to E763. This just saves you having to go in and highlight everything. Okay, so that gives me the data for 220 ohms method 2. We still have the same bin range, so I don't have to change that. We're going to have a chart. We're going to say OK. And click on the graph, drag it out. So that's the histogram for method 2. Now, it's actually better, in this case, we're going to take the data from here and we're going to highlight it. And then we're going to do Control C. We'll go to the other graph and then we'll do Control V here. So these are the two, the histogram for method 1, the histogram for method 2. Right now it's only showing method 1, but we can fix that by clicking on the graph, going to design, select data. So you can see we have method 1 here. What we're going to do is go add, say method 2, that's the name. And for the series values, we'll go over here and highlight the second bunch of data and then push enter. And then say OK and say OK. So now we have both histograms. Let's go ahead and get rid of this more category. So we're going to highlight row 23, right click, choose delete. So you can see that the numbers are pretty close to each other. The histograms don't look a whole lot different. Let's move the legend. So I'm going to click on the graph, go up here to plus, go to legend, and put it at the top. It just gives me more space. Okay, so there's our comparison of the two methods. Not a whole lot different. Now, one thing I'm going to also do is I'm going to show you something interesting. So let's shrink this graph a little bit. We're going to show you how you can go from a histogram to an average. And the way you do it is you take, so this is an equation, so we do equals. We're going to take the bin value and multiply by the frequency and then push enter. Now, these numbers are not, it could be 201 or 200 or 201, but it's okay. We want a comparison here. So we had that equation, this times that, and then we copy that equation down. So that's all these numbers multiplied by all those numbers. Let's do the same thing for the second set. So for the second numbers, you take equals, click on the bin number again. Instead of using this, use that. Push enter. You get 0 because you get 200 times 0. You copy those numbers down. Now to get an average, you add all these numbers up. So you go equals sum, put a left parenthesis, highlight every cell, right parenthesis. So all those numbers added up in that column are that. Copy that, Control C, Control V, so that's all these numbers added up. Now to get the average values, or an approximation of the average values, we're going to take this number and we're going to divide, push escape. We also need to add these up as well, so I'm going to copy, all these are just sums, so I can Control C and Control V, so that's all these numbers added up. That's how many data points we had. Okay, back to this. So to get the averages, we go equals this number divided by this number, and we get 217.85. For this one, it's the same equation except it's shifted over one, so we could actually just copy that formula, I think. And we get 218.1. So that's the difference. It's only 0.3 units difference between the average of these two. So there's really no difference. And the histograms look pretty much the same as well. And we kind of alluded to that. I mean, what happens is you've got your body's resistance in parallel with the resistance that you're measuring. And it shouldn't make very much difference. And you know, everybody got, if you remember measuring your resistance, everybody had different resistance, so everybody's going to be slightly affected slightly differently. I think at the end I'll show you that calculation for these two scenarios, but let's just move on. So let's put some titles on these tabs. So this one I'm going to say is histogram 220 ohms. Now, this sheet 3, let's just get rid of that. We don't need that anymore because we combined the two. So we'll click on sheet 3, right click, delete, push delete. Okay, so that just gets rid of the duplication of the data. So, and let me go ahead and click on sheet 1 here, double click on it, call it the data. Now what we want to do is the same thing, but we want to do it for the 10,000 ohm scenario. So we're going to do the whole step again. So we're going to go to data, data analysis, histogram. Okay. Now our input range is going to be, from our list, we go from 764. I just used backspace to get rid of those. Go back. 1144. Now the bin range we're going to have to change because that bin was for the 200. We want the bin range for the 10K. We're going to create a new worksheet ply with an output. I'm going to say OK. We're going to take the graph. We're going to spread it out so I can see a little bit. So this is method 1. So let's go ahead and change the name here. So we'll go to design, select data, edit, method 1 again. Okay, I just changed the name of the thing here. So that says method 1 now. Okay, so we're going to do method 2, and then we're going to copy the data in just like we did a second ago. So let's click on data, data up here, data analysis, histogram. Okay. Okay, we put it in the next group of data, which is instead of 1144, we start at 1145 and we go to 1535. And we have the histogram. Now, I'm not going to make it bigger because I'm just going to copy the data over like we did. Now there is this 21 with more. That's okay. So, well, let's just click it. We'll ignore the more right now. Control C, go back to sheet 4. Actually, let's go back and let's include more. So we'll include the last thing. Control C, go to sheet 4, put it right there, Control V. So that's my second histogram. That's method 2. So we need to put that in the graph. So to do that, we go to Design, select Data, Add. So the add is method 2. Click on this up arrow key. We highlight the second set of data. There it is. And we say OK. So now you can see there's a big difference because these histograms don't look anywhere the same. We do want to go ahead and move the legend up to the top. So we'll go plus legend top. Okay. So that's good. So let's go to sheet 5. Get rid of that. We don't need that. Delete. And we'll click on sheet 4. Double click. Say histogram 10K ohms. So you can see the method made a big difference for the 10,000 ohms, and we'll see why that is later. We could change the title, so let's double click here, go to histogram. We'll just say histogram for 10K ohms. And then go to the 220 graph, say histogram for 220 ohms. Oops, backspace. Okay. Close that thing. Okay, we still have this thing to do. So what I'm going to do is I'm going to just copy these equations. So I'm going to highlight this area. Okay, I'm going to do Control C. Go to this histogram. I'm going to move this over a little bit, take some space. And go here, Control V. So that just copies the equations. I guess I need to copy this one more time, don't I? Oh, didn't like that. Let's get rid of this more thing. So we highlight the row more and we push delete. Okay. And then we have these equations. We did get rid of more here, didn't we? So all we have to do is, let's make sure everything's in the same location. Yeah, this is row 22. So we're going to highlight, let's highlight these two, starting here, row 24, Control C, go over here, row 24, Controls V. And so you can see the average values, 0.976, 0.996. So not only is the histograms look different, the average values are quite a bit different as well. Okay, so that's interesting. Okay, so those are histograms. Now, the next thing we're going to do is we are going to not do histograms, but we're going to look at the different meters. So we're going to create two new tabs with just data. So we're going to click on the data tab here, and we're going to take the 220 ohm data and move it into a new tab. So let's create a new tab. Go down here to plus. Okay, go back to data. Highlight all of the 220 ohm data. Now 220 ohm data, we're going to use both methods because it didn't seem like it made a whole lot of difference. So I'm just dragging down until I get to 10,000. Okay, now do Control C, go to sheet 6, do Control V. I did forget, I did this earlier. Let me insert a row because I forgot this stuff here, the titles. Control C, Control V. Okay, let's make it a little bigger so we can see it. So this is all of method 1. So let's do we'll say meter comp 220 ohm. We'll do this. Let's go ahead and get the data for the second bit. So we're going to go here and we're going to now highlight all of the 10,000 ohm stuff. So keep dragging all the way down to the bottom now. Okay. Control C. Oh. Control C. Just didn't like that. So let me go ahead and copy it while I have this thing out. Go to create another tab. Do Control V. I'm going to have to steal the heading here. Control C. Control V. Make it a little bigger. We'll call this tab down here at the bottom, meter comp 10K ohms. I should say ohms. Now for the 220, like I said, we're going to use all of the methods, but we do need to order them according to the meter. So we're going to highlight all of this data. So we're just going to drag it all the way down to the bottom. And we're going to sort it. So we go to data, sort. We're going to sort by column B, which is meter. So we got meter 1, we'll have meter 2, meter 3. This is so everybody who did meter 1, that's probably 8 people because there were 4 sections, 2 people in each section. So still a fair amount of data. And let me just put some column headings here. Meter 1, meter 2, meter 3. We had 6 meters. 4, whoops, meter 5, meter 6. And the titles here are going to be average, standard deviation, 2 standard deviations, 5%, and percent of nominal. So you might need to pause it there to get this all set up. And then I click between the rows to get the widths. Okay. So now we're just going to do the average. We're going to do all this calculation. So you've got equals average, left parenthesis. So for meter 1, we're going to go to this column. We're just going to drag it down until we see column F turn to meter 2. So there it is at that point. Then a right parenthesis. Let's do the next one here. So we'll say equals average, left parenthesis. We'll scroll down until we see meter 2 here. We'll click. We'll drag down until we see it change to meter. Oh, wait a second. We're actually, let's go back here. I was looking at the wrong column. Yeah, let's undo that. Sorry. So I'm just undoing here. Okay. Undo. Okay. I was looking at the wrong column. I was looking at method meter. So let's do it again. Equals average left parenthesis meter, do column E. And we're going to look for row B or column B to change to 2. There we go. Change to 2 there. So you can see it does it there, and then you can use the right parenthesis. So that's meter 1. 219. So it's pretty close. 220. Okay. Meter 2 equals average left parenthesis. We'll go down in column B until we see 2. Here's 2. So we'll go over to column E, drag down until we see column B change to 3. There we go. Okay, so it's up to 253. Right parenthesis. Okay, so that's the average for meter 2. For meter 3, average. Okay, now we're going to scroll down until we find 3 in column B. So there it is right there. So we're going to click on that. Then we're going to drag down till we see it, column B change to 4. There we go. Right parenthesis. Okay, so that's the average for meter 3. Meter 4, average left parenthesis, go down column B until we see meter 4 average. So I'm scrolling down here, probably can hear it in the background. Here's meter 4, so do that, drag down until I see it change to 5. Okay, there it happened. Right parenthesis, push enter. 215. Meter 5 equals average left parenthesis. We'll go down to till we see 5 starting. There it is. Click there, drag down till we see 6. Don't have as many of these measurements because we had some empty stations. Right parenthesis, enter. So there it is, 218. And then we do equals average left parenthesis. I'm going to scroll down here on the left to get there faster. So there you see 6. So drag down till the end. Do a right parenthesis. And so there's meter 6. So you can see 3 and 4 are a little bit lower. And it could be because of the meter, it could be because of the resistors that were in that particular, those 2 people. Excuse me. Now let's write these numbers down. So I'm going to, again, write the ranges. This is just so I don't have to do this dragging stuff all the time. So it goes from 2 to 118. See up here, 2 to 118. If I go here, it should be 119 to 253. The next one is 254 to 422. Next one is 423 to 590. 591 to 680. It should be 681. 681 to 763. Okay. So what we can do is we can now do the standard deviation equation, which is equals STDEV, and we're going to go from E2 colon E118, right parenthesis. Okay, so that's one standard deviation. Do the same thing. STDEV, left parenthesis, E119 colon E253. So that's for the second. Meter 2. For meter 3, it's E254 colon E422. So we get that. Next one is STDEV left parenthesis E423 colon E590 right parenthesis. For meter 5, STDEV E591 colon E680. And then finally, the last one is equals STDVE equals 681 colon E763. So those are the standard deviations. So now we're going to take two standard deviations. So we have a formula for that equals 2 times the previous value. So that's two standard deviations. 95% of the data should be within plus or minus 2 standard deviations. Now, the nominal accuracy of these resistors is 5%. So if I take, these will all be the same, 220 times 0.05, that's 5%. That's 11, plus or minus 11. So you can see that all of our meters and all of our values are within much less than 5%, or the value corresponding to 5%. Now what this means is percent of nominal. What we're going to do there is we're going to take the average value and divide by 220. So it's, multiply it by 100. The reason I did that, you'll see in a second here when we do the next group, is that you can see meters 3 and 4 are 98.2 and 97.8% of nominal, whereas the other ones are much closer. So the question is it these 2 meters that give lower values, or is it just something to do with the randomness of the resistors that everybody just happened to be having in their kit? So that's it. What do we figure out? Well, meters 3 and 4 have lower values, more less than the nominal than the other ones. You can see that both here by looking at the average values as well as looking as the percent of nominal. But even so, they're still within, even if you take this number and subtract 2 standard deviations, it's still going to be within 5%. So now we're going to do the same thing here as we did there. So we can copy the headers over. So do Control C, Control V. Do these as well. So highlight those, Control C, Control V. Now, as far as the values, we have to, we're going to have to, they're not the same rows. So we're going to have to go in and figure out what they are. So I'm tempted to turn it off and let you do it, and then we'll compare answers. So I'm gonna pause the recording, and I want you to find out. I'll do one of them, and then I'll let you do the rest of them, and then we'll compare our numbers. So you do average equals average. We're doing meter. Oh, we gotta escape. We haven't ordered our stuff yet, so sorted our stuff. So we're gonna highlight. Oh, there's a couple things we're gonna have to do here. One thing we're gonna have to do is get rid of all this method 1 stuff, because these numbers were all over the place. So we're only going to use, for the 10,000 one, we're only going to use method 2. So to do that, I'm going to show you, we could highlight the rows, but then I'll delete what I already have here. So what we're going to do is, I think they're sorted according to method, so I don't really have to resort them, I don't believe. Yeah, so all the method 1 are first. So what we'll do is we'll highlight this, we'll drag it down until we see method column F to change from 1 to 2s. Because method 1 was not a good method for the 10,000 ohms. Okay, so you highlight that. If you right click it, you can say delete. And what we want to do is we want to shift the cells up. If we shift the entire row up, it'll get rid of this stuff. Oh, we still have one we need to get rid of here. Right click, delete, shift cells up. Okay, now you can see all of them are method 2. The next thing we have to do is sort it according to meter number, just like we did before. So we're going to highlight all that stuff here. Oops. Didn't have to go as far. Okay, so I've highlighted that. Go to sort and sort by meter. So now we've got all the meter 1 first, and we'll have meter 2. I'm going to click here, double click here to get this a little wider. So now I'm going to show you the first one, equals average, left parenthesis, meter 1. So we'll highlight column E until column B changes to 2. There we go. Put a right parenthesis, push enter. So that's the average for meter 1. Okay. So I want you, and you might as well, we'll get the numbers later. So I'm going to pause it, and I'm going to do these 5, and you're going to do them, and then we'll compare our numbers and hopefully it's the same. Okay, so these are the averages I got. Now, what we're going to do now is the standard deviation. So, remember we can click on the cells and we can write these ranges down. So I've got 2 to 81 for the first range. And I'm going to again pause it so you can write down the other 5. Okay, so, this one I said was from 2 to 81. So what we'll do here is we'll say equals standard deviation E2 colon E81. And we get 0.04874. Okay, again, I'm going to pause it. If you got these numbers right, then you got the ranges right. Oh, something's wrong here. What happened? Well, let's go down and look here. Oh, I know what happened. Yeah, I forgot about this. So that says something is weird is going on. So let us look. And this was because I entered the data wrong. Yeah, you can see what I did. And that's why I had those high numbers earlier. So let's go back. We're going to have to go back and fix these. But that's okay. Sometimes you make mistakes and you have to realize when. So what I'm going to do is I'm going to create a column or create a thing here where I'm going to take these numbers here. I'm going to divide by 100. So I'll get 9.9, which are the right format. Okay, then we're going to copy that. This is the only place I made the error. I'd forgotten about it when I did it again. Okay, so now I've got all the data in the right format. So we're going to highlight the columns, highlight that data. Then you go to Home, and actually no, let's go back here again. You highlight the data. We're going to do Control C. We're going to click the top. We're going to go to Paste, and there's a special paste function that's paste value, because right now I have an equation. So right now all that data is done from an equation, but now if you do paste value instead of an equation, these are actually numbers now. So then I take these numbers, I'll do a Control X to cut them. I'll come over here to this where I want to replace them, and I'll push Control V. So you can see now those are all the right format. So if I go back to the top, I'll see they look much better now. Okay, so that was good. I found that. And we'll go back and fix the other ones in just a second. Well, we kind of threw out the data. I think we'll just leave it at that. That's why there was those numbers that were high. If I go back here and I deleted that data here, and the reason with those weird data points in there was because I had that stuff in there incorrectly. Okay. Now we got, so now I'm going to pause, and I'm going to put the standard deviation equation in for the other ranges that you hopefully have copied down. Okay, so we're back. So these are the standard deviation values. So again, we can calculate twice the standard deviation. So it equals here times 2. And then we're going to copy that over here for all the other ones. Now 5% of nominal, so it's 10K times 0.05. So you can see again, 2 times the standard deviation is a lot less than 5%. So they're way within 5%. They're close to 1%. And again, the percent of nominal, this was to see if it was meters 3 and 4 or whether it was the resistors. So to get percent of nominal, we're going to take these numbers, divide by 10, multiply by 100. So this is 99.58 of nominal. So, if we look at meters 3 and 4, you can see again they are lower than all the other ones. If we looked at for the 220 one, we see that meters 3 and 4 were lower than all the other ones. So that would make me believe that it possibly is that meters 3 and 4 are giving lower values. And I've copied that over there. Okay. So what did we conclude from all this data that we took and I spent a huge amount of time putting together? Well, we learned that method 2 was, for the higher resistors, was vastly superior to method 1. Whereas for the 220 ohm, it didn't make that much difference. We also saw that just comparing meters, that it looks like meters 3 and 4 are reading a little low compared to the other meters, but that the accuracy of the meter plus the accuracy of manufacturing is putting these values easily within the plus or minus 5%. So they're manufacturing them to better tolerance than they're advertising. So the only thing I have left to do is just to explain why the method 1 and the method 2 gave us different results. So let me pause for just a sec. So what we have in this case is we have a 220 ohm resistor in parallel with a person. Now, that was more like 500,000 ohms. So if we calculate the equivalent resistance, which is what we're measuring with the resistor when we use method 1, we get 1 over the equivalent resistance is 1 over R1 plus 1 over R2. I'm just going to do the calculation quickly here. You get 1 divided by 220 plus 1 divided by 500,000, and then take the reciprocal of that, and I get 219.9 ohms. So you can see that for this small resistor that it only makes a tenth of an ohm difference. Now when you have the other case where we have 10,000 ohms, in parallel with 500,000 ohms. And we do the same equivalent resistance calculation. 1 over the equivalent resistance is 1 over 10,000 plus 1 over 500,000. We get the equivalent resistance. So I take 1 divided by 10,000 plus 1 divided by 500,000. And then I take that to the minus 1 power. And I get 9,800 ohms versus 10,000 ohms. So you can see it makes a much bigger difference when you have the higher resistance. If we go back to our results here and we look at the difference in the values here, it's about that amount. Is it? Yeah, 976 versus 996. That's about 2,000 ohms. So that matches up really closely. Whereas when we looked at the histogram here, we had 0.15, which probably is just the difference in the resistors that we measured. It's probably not due to the measurement technique. Okay, I know that's long, but hopefully you learned a lot.